life, we're called upon to compare fractions. The most important thing to remember probably when you're comparing fractions is that the larger the denominator, the smaller the number. It seems counterintuitive, but look at the size of the piece. When you have only an eighth of something, that's not a very big piece. Compare that to a fourth. That's only half of a fourth, smaller than a fifth. However, when you start combining multiple pieces, then it can be a little less obvious that a 2/8 is smaller than, it's actually larger than, a fifth. See that? 2/8 is actually larger than 1/5, although 1/8 is clearly smaller. It's easy to compare fractions with a common denominator. 3/8 obviously is less than 5/8. Now, this is a good time to remember that this symbol that looks like an L reminds us of an L, it's kind of tipped, stands for less. Can you read that? L-E-S-S, less. It's the other way, it doesn't look at all like an L. Now, these two aren't too difficult to compare because you can see that 1/3 is twice as big as 1/6, particularly if you can picture that in your mind. If you are going for the key lime pie and somebody says, would you rather have a sixth or a third? A sixth is half the size of a third, so that's not too difficult to compare. And you can see that 4/3 is the same as 8/6, particularly if you're very careful in marking the pieces. But things start getting more complicated when you're comparing something like thirds and fifths. And some people resort to dividing. 2 divided by 3 is 0.66666, which you round to 0.67 or so. And 3/5 will divide out perfectly to 0.6. So you can get the comparison. Here's that greater than sign, that 2/3 is greater than 3/5. But looking at it graphically, it's starting to get a little bit tricky, and you have to be very careful in how you measured out all these little dividers to get an accurate comparison. Same here with 7/9 and 8/11. I guess it looks like 7/9 is bigger, but that's only because I draw so well. And if you actually divide out 7 divided by 9, you'll see it's 0.8, which is greater than 8 divided by 11, or 0.72. Another way to compare that also makes it possible to add and subtract your fractions is creating a common denominator. And immediately when students hear common denominator, it sounds like a lot of work, and they're, why not just put everything in decimals? Well, there is a good reason for that, and that's the accuracy thing. If you look at 2/7 in your calculator, you can see it's 0.285714, and then it starts repeating this 0.2857, and on it goes. And same with 8/21s, it's a repeating decimal, and who knows how far out before you start getting repetition. 1/3 is easy, it's just 0.3333, but if you had to add all three together, oh my goodness, it's much easier to add these with a common denominator as 21st and see it's just 1. And it's also accurate. Here, when you start rounding and all that stuff, you're going to lose information. Before we can say much about common denominators, it's hugely important that you understand what equivalent fractions are. 1/4 is obviously bigger than an eighth, but if I duplicate the eighth, you can see that 2/8 is the same size or equivalent to 1/4. Those are equivalents, 2/8 and 1/4. We'd write that 1/4 equals 2/8. But comparing something like fifths to thirds gets a little bit more complicated. In fact, what we end up doing is cutting the pieces smaller until we find a slice that matches. We can take fifths and cut them into 3 pieces each and come up with 15ths. Count them. 1/5, 2, 3, 4, 5/5 is the same as 3/15. 1/5 is the same as 3/15. 5/5 is the same as 15/15. Go ahead and play with that idea. See if you can pull it together. Over here, the thirds, if I count each one of these pieces, you'll see I have 5 pieces in each third. That's a total of 15. Look, I have 15ths again. 1/3 is the same as 5/15ths, and 1/5 is the same as 3/15ths. See if you can put your mind around that and get this idea of equivalent sizes, equivalent pieces. We can't compare fifths and thirds very well. If I double the fifths, it's too big. If I half the thirds, it's too small. But if I put them both into 15ths, I have a fair comparison. I can compare 3/15ths with 5/15ths. I can compare 1/15th with 4/15ths because the size of the pieces match. That's the idea of getting equivalent fractions. So how did we get from fifths to 15ths? We cut the pieces smaller. In fact, each piece we divided by 3. Dividing by 3 is the same as multiplying by a third. But wait a minute, I can't just corrupt my piece like that. Certainly 1/5 times a third is not equivalent to 1/5. But if I do the same to the numerator as I do to the denominator, I'm simply multiplying by 1. 1/5 times 1 is still a fifth, but look at the way it changes the looks. 1/5 and 3/15ths look a lot different, but it's the same value. We do the same to the third. We're going to multiply the third by 5/5, which is also 1, like this. 5/5, 5 divided by 5 is 1, and if I multiply straight across, I get 5/15ths. Now I can compare 15ths to 15ths. So clearly 1/5, which is 3/15ths, is less than 1/3, that is 5/15ths. The beauty of being able to compare when your denominators match up is to multiply the 2 denominators that you have. Basically, you're cutting your sevenths into 10 pieces and your tenths into 7 pieces. And either way, you're going to get 70ths. For both fractions. Now, of course, you can't just say 3/7 is the same as 3/70. That doesn't make sense. Pieces are much smaller here. What did you do to get the 70ths when you were starting off with sevens? Well, what you did was you multiplied your 7 by the 10. And what you do to the denominator, you have to do to the numerator. So let's do that. Let's multiply the denominator by 10, but also the numerator. We know this is legal to do this. We're not changing the value of 3/7 because we're just multiplying by 1. 10 divided by 10 is 1. 1 times 3/7 is 3/7. But we dramatically change the way it looks. 3/7 becomes 30/70. And if you take your hand and cover the zeros, you can see 3/7 hiding in there. Multiplied by 10 over 10 is 30/70. And so what did we do to the tenths to turn them into 70ths? Well, we would have to multiply by 7. So what we do to the denominator, we do to the numerator, so we don't corrupt our fractions. We cannot pretend that 4/10 is the same as 4/70. It's not. You have to multiply the numerator by the same number you multiplied the denominator by, and you get 28/70. Now you can clearly see that the left fraction is bigger than the right. In math world, rather than write out the left fraction is bigger than the right, we simply use this lovely shorthand, greater than. 30/70 is greater than 28/70. By that same token, we can say that 3/7 is greater than 4/10. Now, finding a common denominator, it always works to multiply these two, and that can be your common denominator. You can multiply 3 by 11, 77 by 11, and then 5 by 77, 11 by 77. You can get a common denominator doing that. However, you've probably also heard about least common denominator, because if we actually multiply 77 times 11, you get 847, which is not a very friendly number. Instead, if you know a little bit about multiplication facts, you know that 11 times 7 is 77. If you don't know that, now is a good time to memorize your multiplication facts. You can do that. I guarantee you, if you were in my class, you are capable of getting your multiplication facts down, and I advise you to do it now. Better late than never, but the longer you put it off, the more agony you're in the rest of the year and years to come. So please take care of that if that's something you haven't done yet. Okay, but back to the idea that instead of getting this humongous number, 847, let's just multiply top and bottom, numerator, denominator, by 7s. And what do you get but 35/77? Not a bad number to work with at all. And then you just compare with the 3/77 that you already have. And clearly, the 3/77 is a whole lot smaller than the 35/77. In the case of comparing ninths with sixths, again, you could go with 54ths, but that's kind of an ugly number. A smaller, the least common denominator would be, well, let's see. This is divisible by 3, and so is that. And so you have a common factor here. You don't have to go as big as 54ths. Let's think about what could be smaller. Well, 2 times 9 is 18. And think about it, 3 times 6 is 18. Why not use 18ths? Since you know both 9 and 6 go into 18, and that's the smallest thing they both go into, it's a much nicer number. In fact, you just end up comparing 8/18 with 3/18, and clearly the 4/9 is larger, greater than the 1/6. The key thing to remember is that in order to change your denominator, you have to multiply the numerator by the same amount. Once you have that down, you have a skill that is transferable to a multitude of different things in math. So, oops, did that one wrong, didn't I? That one goes over here. And the 4/9 you would multiply by 2 over 2. Like that. There you get 18ths. There you get 18ths. Now it's time to start practicing.